Hello and welcome back. In a slightly discombobulated state, as any of you who are just watching Andy Randall's call in the other room, I think we've hit one of the problems of doing this sort of thing at home, which is my belated Uber Eats driver has just arrived, and I'm about to have to go and pick up my food from him dressed like the Mad Hatter. But while I'm waiting for that person to get all the way up the lift, let me introduce Daniel Bryant, long-time advocate of the Software Circus, always working on interesting stuff and speaking about it very publicly. Long-time writer and editor at InfoQ. And today, Daniel's going to be talking about the past, present, and the future of cloud-native API gateways. Now, Daniel, I don't know if you've been watching many of the talks, but everyone gets some canned applause.
Nice, thank you. Appreciate that.
My compliments on the outfit, and without further ado, take it away, please.
Thank you very much, Mark. I've got to give a shout out to the Calico folks, Tigera folks. It's actually a Calico cat, been today co-opted into a Cheshire cat. Yeah, so shout out to my Tigera people there. So welcome everyone to the past, present, and future of cloud native API gateways. So what I want to do today is give you sort of like 3 key takeaways, if you like. The first one is that edge gateways, edge proxies, API gateways have pretty much undergone a series of evolutions driven primarily by architecture, the software architecture upstream of them. Cloud native is becoming a thing, right? Everyone's adopting microservices, Kubernetes, moving to public cloud, or not everyone, but a lot of us are, I should say. This changes the architecture, obviously with microservices, but it also changes the workflow. We're moving from projects to products. You build it, you run it, ownership of services. And therefore, my pitch today, really, I'm going to focus on cloud native API gateways. That's kind of my thing at the moment. But my call to action really is think about your platform. If you're delivering web-based software, you are deploying applications onto a platform. And I've seen quite a few folks move, excuse me, I've seen quite a few folks move their existing platform, their traditional platform, into the cloud without giving it much thought. And my pitch really today is build your platform intentionally. Now, I'm going to focus on the gateway. Hopefully, there's a few takeaways that are general to the platform. If you are building a Kubernetes-based platform, you're building a Mesos-based platform, be intentional about your design choices. Don't just take the old way of doing things and put it into the cloud. This is me at Daniel Bryant UK on the Twitters, LinkedIn, GitHub, and so forth. I work mainly as a product architect at DataWire these days. We do have the Ambassador open source API gateway, so own my bias there, but this is going to be a general talk. As Mark mentioned, do a bunch of writing for InfoQ, a bunch of podcasts for InfoQ. My main background is Java dev. I wrote this book with my buddy Abraham Rimprez a couple of years ago now, so you can check on that on the O'Reilly space too. But without further ado, let's go into the main content. Now, when I use the word edge, I'm talking about the boundary between the data center and the users. Yeah, maybe your Kubernetes cluster and the users, or Amazon and the users. Edge is quite an overloaded term. You have kind of edge, say, in terms of Kubernetes clusters running on premises, or in restaurants, kind of close to the edge. And you also have like IoT and actual devices at the edge. But the edge I'm talking about today is the boundary between the data center and your users, kind of where the API gateway, edge proxy, all that kind of good stuff sits. Now, the thesis I mentioned in the TLDRs, the evolution of the edge has been driven by application architecture. Now, my career spans like roughly 15 years or so. So I want to take a quick trip, or 10-minute or so trip down memory lane, and I'll pull out some of the threads further on in the presentation in the next like 20 minutes or so as well. But back in 95, I was still in school pretty much this. I was, this new Java thing was popping up at the time. I was learning how to code when I was in school. The primary architecture was the Java monolith, or some form of monolith. At the time, like browsers were only a new thing. The internet was only pretty new, right? We weren't sure whether browsers were going to be the dominant way to consume content, or things like Java applets. And with throwback there, everyone worked on Java applets. But obviously, we know browsers have won. But back in the day, we weren't sure how people were going to connect into these monolithic apps backed by a database. The hardware load balancer popped up. Basically, it was sysadmins owned this thing. They were focused on high availability and scalability. The application servers, the web servers behind this hardware was specialized in making sure things stood up. And if things did fall over in the back end, you could route accordingly and keep high availability. As we move into 2000s, I was at university, college, studying here then. I was doing a bit of web dev on the side, still very much classic monolithic style applications. .NET was kind of rising to fame. ASP.NET was super popular at the time. This was the rise of the software-based load balancer. Massive work, HA proxy, nginx, tip of the hat to them. A lot of us now are loving Envoy, and with good reasons, but these proxies paved the way. As folks were scaling out their back-end architectures, it was prohibitively expensive to scale the hardware load balancers with them. You got more malleability with the software load balancers, or you could deploy them on commodity hardware. We as software engineers were more happy working with software versus the hardware. And although really these software load balancers were aimed at sysadmins still, it's kind of pre-DevOps this time, there was very much a focus on this kind of malleability of using software. High availability and scalability were still the kind of goals, but we started adding in a bit more load balancing, a bit more sort of dynamic load balancing, software-based load balancing. We added in sort of more, we didn't call it observability back then, but kind of more metrics and more logging at the edge of our systems. We were looking into sort of layer 7, the application layer 7, like HTTP, as well as the layer 4 stuff. So 2005, this is Web 2.0. This is huge. When I left university, this is all like the jobs were all Web 2.0, e-commerce, AJAX. Yeah, shout out to AJAX. This basically revolutionized the game. Before it was request response. It was, we'd make a request at the edge, a heavy response would come back, basically a whole HTML page. With AJAX, you could dynamically update the DOM. That was game changing at the time. But it did move the architecture style, the edge, the way you interacted with the edge, from no longer was it request, massive response, request, massive response. It was request, massive response, small request, small response, small request, small response. There was many more requests coming in. So this is when we saw the rise of what we call ADCs, application delivery controllers, pioneered by F5, nginx, all these good folks here. This was about accelerating the edge. Primarily, still the target was sysadmins, but it was about, say, SSL offload, moving some of the TLS termination, SSL termination, moving that from the app servers, from the web servers, into specialized hardware, into specialized software to do this kind of thing. Improve caching, things like that, because you were making many more requests at the back end as the architectures were changing to dynamically update the front ends. This was very much hardware driven, F5, big IP, all this kind of stuff. nginx were leading the way here as well. The irony now, of course, is F5 have acquired nginx, so it's one and the same company now, but these are the kind of pioneers in the space of the ADCs. 2010, the kind of I era, I was doing a lot of work on Google Maps at the time, using their API, Stripe, mashing up things. The idea being we'd use all these sort of freely available APIs to mash up and deliver services. And this is where we see the rise of the first API gateway. Mashape, the company that produced Kong, ultimately, Mashape were heavily involved in this. Aggie, Marco were doing their stuff. They're based in Italy, I think, at the time. We're creating this sort of ecosystem where you could mash up different APIs and produce services. Ultimately, Kong was produced as Kong, the API gateway was produced after that. But the focus was not only on sysadmins as users, but on API developers too. And the idea being sort of API management came into being a thing. Layer 7 routing based on HTTP metadata, you're going to be routing to different places, and you have sessions and a lot more activity sort of at the HTTP layer. There was also a big push towards dev portals, being able to onboard developers to your APIs, analytics, monetization. You mash up these APIs, you try and make money off them. It was kind of challenging doing that, but as in this was the driver of the first generation of API gateways. 2015, this was when you see kind of the big unicorn companies doing really well, but also struggling. I think Twitter was around 2012, 2013. We used to see the fail whale quite a bit. The servers at the back end couldn't handle the load. Still had ADCs up front. They were still doing TLS termination, SSL termination with specialized hardware and so forth. And they recognized the power of breaking the monolith up. They were bringing pulling out these microservices, these mini services, but the monolith was still being a router. Yeah. Most traffic was going through, and in Twitter they had their famous monorail. It was a Ruby on Rails monolith. Traffic was still going through the monolith. And of course, when the monolith went down, so did all the satellite services. Yeah. This led to the second generation of API gateways. We pulled out the routing into a specialized bit of kit, be it software, hardware. Then the monolith or the monolith went down, the API gateway kept going and could route traffic accordingly. You still often had ADCs up front, Varnish caching, Akamai as a CDN, for example, but the API gateway was getting more of its final shape that we see today now, and all these upstream services were proliferating as the likes of Twitter and Facebook, and well, not Facebook actually, but Twitter, Google, Amazon were doing microservices. It was becoming more things at the edge. The users were still sysadmins target, but definitely increasingly app developers themselves, API developers. More and more developers were expected to understand how to release services, release APIs via the API gateway. We were starting to centralize some of those cross-cutting concerns into the API gateway at this point, with all the routing, all the layer 7 awareness, based on this session token, send it here, based if, the person's using an iPad version, whatever, send them here. We're starting to get a bit smarter at the sort of application level of the application, the networking stack, like the OSI stack. We're starting to use metadata at the top level, layer 7, to make decisions based on what we should do at the API gateway, where we should send it, maybe we should block it because it's, it's kind of like an invalid request, these kind of things. There's a lot more smarts going on in the API gateway. If we take a pause now and come to present day, cloud native, totally a thing. Software Circus is all about that. I've thoroughly enjoyed my previous previous visits, I should say, at Software Circus. There's been lots of great conversation. Kelsey Hightower, Adrian Cockcroft. I know we're going to see them later today. I've learned a bunch from them around sort of this cloud native world that we're all quite happy in these days. And the premise really has been driven by decomposition of functionality. Microservices, basically modularization. David Parnas was talking about this from the 70s, but our latest thing is using a network boundary, a hard boundary, bounded contexts, and then exposing the functionality in those sort of contexts via APIs, via HTTP APIs, via gRPC APIs, that kind of thing. The key goal here is decoupling. There's always some coupling if your services are working together. You want to decouple as much as possible so you can build, release, operate independently and scale independently. It's that whole thing, products. You're building products and you want to independently release and scale them. You're not building this one big thing anymore. We're seeing a rise of, I did a whole bunch of work on Mesos when it was becoming a thing. Now it's Kubernetes. We're deploying apps to many different locations. We've still got our, bare metal. We've still got our on-prem. We've got now Kubernetes, public cloud, private cloud. We're using all these different protocols where we have different requirements of load balancing now, which is interesting. And there's different auth requirements, OAuth versus sort of like, session-based logins and all these kind of things. There's a lot more going on behind the API gateway or at the integration points now. Bringing this all together, the past and the present, really these sort of cloud native API gateways that we're seeing now, they kind of combine all these things. There's some notion of API gateway type management capabilities. Number one in the top left here, authentication, dev portals for onboarding, metrics, all that good stuff. There's some notion of application delivery controllers, ADC-like functionality, TLS offload, timeouts, retries, rate limiting, all that good stuff. And then clearly the gateway has to have some kind of dynamic back end. People were using Zookeeper to keep track of their apps, or Console to keep track of their apps. This because things are a bit more dynamic now, like the architectures of sort of microservices, functions are a bit smaller. We're doing sort of more dynamic allocation of resources, and things come up and they disappear. So we need to bake that into our gateway too. But really, for me, microservices, projects to products, like this kind of cloud native methodology, if you like, we sort of labeled it as microservices. I think microservices is one of those words that means many things to many people, but small focused services, they kind of lead to an even bigger change. And this really is the notion of you build it, you run it. You're now working on these products that happen to expose APIs. You're working on a service that happens to expose a sort of user-facing API. And developers, we're often on call now. If we build it and we run it and it breaks, we need to fix it. There's this notion, the Netflix team, I really like the notion called full cycle development. And it's really empowering developers to do everything that they need to be able to do, driving like everything via self-service. It's a big drive. You look at the Google workflow, primarily focused on self-service, minimizing that friction from a developer having an idea to coding, to testing, to deploying, to releasing, to observing, and starting again. You're minimizing all the friction. You don't want to be raising tickets, that kind of stuff. And there's a fantastic blog post on the Netflix blog there. You can see the link at the bottom. They talk much more about this concept of full cycle development, but really it's about empowering developers self-service. And this really, it's a change in the workflow. Regardless of your actual architecture style, now we're looking, moving from projects to products, we're looking increased ownership for developers, and this need to, if something breaks, we need to find out where it's broken and fix it. If we're releasing a new product, we need to be in charge of when we release it. I think, therefore, the thesis that I mentioned at the start kind of changes. the thesis, the evolution of the edge, I think in the future, or the DataWire team and I'm obviously presenting today, but I've got to shout out my whole team have come up with these ideas. We think the evolution of the edge is going to be driven by application architecture, but also application development workflows. If you think about the opportunities we've got now, we've got monoliths, we've got microservices, maybe macro services. You see Uber and the folks talking about that. We've got nano services, we've got Lambda, these kind of things. We have got the whole spectrum really of architectures available to us. We've always had them, but now they're packaged really nicely for us to use. I think the biggest challenges over the next few years is going to be developer workflow, developer experience in particular. I think is going to be really key. The two biggest challenges I wanted to highlight when I see folks moving from sort of a traditional way of working into the cloud, the two biggest challenges, the first one is scaling edge management. Back when I was doing my Java dev, I controlled sort of the back end here. I was like the dev team and we controlled the back end. If we wanted to do some kind of cross-cutting functionality like rate limiting or tracing, we typically use the library. We were doing some kind of circuit breaking, we might chuck in Hystrix or Spring Cloud Gateway, all that kind of Spring Cloud stuff, for example, the Java world. But I was controlling, because it was, I was just using Java, it was language specific, I could plug in the libraries and I could make my progress. Occasionally, I needed to reach out to the ops team who controlled the API gateway. Might to open a port or just some kind of config that I can't do in the app. And therefore that was typically ticket driven. Right? I raised the Jira ticket, ops team had a look, they gave me some feedback, they fixed it, and it took a while to do. So I had to bake this into my kind of plans. I knew if I was going to release some new functionality that needed a new port, I'd have to respect the SLA or the service level agreement of my ops team. They might turn around tickets in 24 hours, 48 hours. I knew I had to make sure that my release schedule was respectful of that. This is really challenging when we're actually trying to scale microservices. Yeah, there's, we've pulled up the cross-cutting functionality into the API gateway now because we're language agnostic, right? We can have Java, Go, whatever in the back end, but we've pulled up all our things like retries and caching and so forth into the API gateway, into the edge kind of functionality. But there's many more things now on the back end. Many more microservices are exposed to the edge. You kind of obviously often the breadth of functionality kind of gets scaled out away from the monolith, and you have several entry points into your app. Now, tickets here don't work because again, we're trying to go as fast as possible. If I make a mistake and have to raise another ticket and get some feedback and raise a ticket, this slows me down as a full cycle developer, as a developer that needs to make progress fast. The second challenge is around supporting diverse edge requirements. I mentioned a few times, many of us are familiar with JSON over HTTP or XML over HTTP, the kind of classic kind of REST type approach. I'm using a lot of gRPC these days, great for binary protocol, bit faster on the wire, nice strong contract. You can use contract definitions like things like packed and Spring Cloud contract with REST and with HTTP, but gRPC and protobuf give you that contract, which is really quite nice. And I'm using a bunch of WebSockets. I'm seeing things like even RSocket pop up. There's many protocols now at the edge, and our microservice can use the best protocol for its use case, which is kind of nice. No longer is it one monolith. We can choose what to do. And we can also, we want to mix and match the cross-cutting concerns. Some services might have auth, some might not. I want retries on some things, but I might not want retries on transactional services because maybe I've already got the retry logic baked into my app. I don't want to retry the wire protocol if I'm already doing the kind of application level retries. And caching is a classic. Caching, I've wasted many a day to my life with incorrect caching of my service somewhere. So we want to, as developers, we want full control over that caching at the edge, right? And and again, this stuff is kind of challenging to do if you're having to raise tickets all the time. Let's skip through that. Broadly speaking, in the work I've done consulting, the work I'm doing now at DataWire, I'm seeing three strategies for fixing this, particularly if you're moving something like Kubernetes, and could be Mesos, could be something else, ECS, for example, Amazon, but Kubernetes I'm doing the most work with these days. And the three strategies we'll kind of broadly step over now. I've got roughly 10 minutes or so left. I've got some a blog post on the website, so you can pop along to the Get Ambassador website and check out the strategies in more detail. But broadly speaking, I see folks trying to manage this, when they're moving to the cloud, is they either deploy an additional Kubernetes API gateway and kind of pass through from their old gateway to the new one. They either extend their existing API gateway and kind of plug it into Kubernetes somehow, or they deploy a full InCluster edge stack, as we're calling it. And that's if you're greenfield, that's pretty much what you do, right? You deploy everything that you need at the edge, typically into your Kubernetes cluster, maybe the CDNs outside, maybe the WAFs outside, but primarily you control everything via the Kubernetes config. Briefly stepping through this now. So the first strategy, deploying an additional API or additional Kubernetes API gateway, you typically, this is when, like, say, some skunkworks project spins up a Kubernetes cluster, and then they deploy an API gateway into this Kubernetes cluster, and they kind of either pass like their existing API gateway, through to this new API gateway, and the old traffic, the existing traffic, goes straight through to the services as they're running now, or they might spin up an API gateway sort of to the same level as the existing API gateway. The new gateway is in the Kubernetes cluster, but we're routing at the sort of layer 4 load balancer, like the edge load balancer is making the decision based on domain name, IP address. It either goes to the old world or the new world. Yeah, both ways work fine. In terms of pros and cons, there's minimal changes to the edge infrastructure required. You're literally spinning up a new Kubernetes cluster with a new gateway. Developers are, putting their services in, making the appropriate tweaks to the API gateway within Kubernetes. And as long as you can pass the traffic through from the load balancer or the existing API gateway into your new Kubernetes world, everyone's happy. The migration strategy is easy. You spin up your new world. You can lift and shift some services from the old to the new if you want. You don't have to. You can leave these things running side by side. The cons, though, my experience, is the increased overhead of working with 2 gateways. I've had some gnarly debug sessions where the Kubernetes gateway wasn't working properly, and it's because the existing upstream API gateway was stripping out headers. So we thought we were doing a straight pass-through from the old API gateway into our new Kubernetes cluster, but it was stripping out some of the layer 7, the HTTP headers, and it was causing all manner of confusion with our ingress in our Kubernetes cluster. Debugging there was hard enough. It is challenging to expose some of the functionality you might want to tweak, say in the traditional gateway, the existing gateway, in the Kubernetes world. So if I'm in the Kubernetes world, I still may have to raise tickets to get things changed in the API gateway above or the load balancer above, which can slow me down sometimes. If we look at extending the existing API gateway, this is quite a popular pattern where you leave the gateway as is, and you don't deploy an API gateway into your Kubernetes cluster. You just typically deploy some kind of ingress controller. And the controller looks at your Kubernetes services, looks at the annotations, the metadata of the Kubernetes services that we as developers may write. We do apt, expose this service on this endpoint. And the controller in Kubernetes loops out to the existing gateway and makes the config calls there. So Citrix do this, I think, quite a bit. A lot of the hardware-based companies do this. The hardware is controlled by an SDK or an API outside of the Kubernetes cluster, and their Kubernetes Ingress controllers simply look at annotations on Kubernetes services and then they translate that into the appropriate calls to the out-of-cluster API gateway. Yeah, and that works quite well for for certain use cases. The pros is you're reusing your existing tried and trusted gateway. There is only one gateway in there, and you're leveraging all your existing infrastructure. You're kind of putting on the new world to the side. The cons is that the workflow must change to preserve a single source. Now, you've got the classic developers writing config for the API gateway. Classic config of the API gateway. Sorry, I lost my train of thought there with the time check. Apologies, everyone. You got some developers writing the config for the API gateway out of bands, and you got some folks writing the API config in the cluster using Kubernetes YAML, for example. And you've got to make sure to marry those two up and avoid conflicts. Really quite tricky there. And sometimes there's limited control in your Kubernetes annotations to tweak the gateway too. The final strategy is deploying an in-cluster edge stack. This is going all in. We've got Ambassador, you've got Contour, you've got Glue. There's many kind of cloud-native API gateways, many of them based on Envoy. There's Traffic. There's a bunch of other ones as well, or Trafic, sorry, a bunch of other ones. And this is kind of, going all in. The ops team typically own the edge stack, if you like, but we as developers configure via Kubernetes YAML to make the tweaks to the gateway as required. And now the thing with this, it's super, it works well, it's super efficient. We as developers can control all the edge stack effectively, and we can do things like single source of truth. We can do things like GitOps. Haven't got time to go into that today, but GitOps by hat tip again to the Weaveworks team. Fantastic sort of idea around declarative code using control loops to keep it all looped together. And the cons, it's potentially a large architecture shift, right? If you're greenfield, this is fine. If you're brownfield, this is going to be harder. And we typically have to learn more things about new proxy technologies. If you're bringing in Envoy to your stack, fantastic bit of kit, have to do a bit more learning compared to maybe your existing hardware load balancer. So wrapping up, coming super close to time here. In conclusion, edge gateways, API gateways, proxies have undergone a series of evolutions over the years, driven primarily by architecture. hardware to software, saving cost, more malleable. Layer 4 to layer 7, we're looking into the HTTP requests now and doing routing decisions based on that. And we're moving from centralized management to decentralized. We as microservice developers, we want to be able to independently release and control things. These are the two things. If you're moving to cloud native way of working, and you're using microservices, using Kubernetes, you want to scale your edge management without tickets, and you want to support multiple protocols and multiple cross-functional requirement config as well. Bottom line is choose your solutions intentionally. Definitely, I've talked about the API gateway. It applies to the whole platform. Don't just lift and shift your old way of working into the cloud. To get the best out of the cloud, you have to make changes all down through the stack. For the API gateway, where I've been working at, hopefully these are sort of a few hints to understand where you might want to make a few changes. This is me on the interwebs. You can find more details there on the Ambassador website. Doing a bunch of podcasts. Just yesterday, I pushed a podcast with Kelsey Hightower. Now, Kelsey's a buddy of Software Circus and presenting it on today. But you can hear Kelsey and I chat about some of these things I've talked about now in the podcast. You can find me in the DataWire Slack, and you can also find me on the interwebs and Twitter at Daniel Bryant UK. So at that point, I say thank you very much.
Okay, where's my... was fantastic. Here we go.
Cheers, Mark. Thank you, everyone.
Yeah, great.
Thanks, Mark.
You did that with literally 20 seconds to spare. Thank you so much for staying on time, Daniel. We're having an issue with that today. You put all the slides up there for where people can find more information. All these slides and the videos will be going online later. And I'm sure if you want to reach out to Daniel through the Brella app, you can do so, and he'd be happy to speak to you. Thanks again, sir. I really appreciate it.
Thanks, everyone. Appreciate all the effort.
Bye-bye.